again, Jeff Scott of Blackhawk Technical College. I've decided to make the lectures for Chapter 8 for both the 152, 142 C# and 152, 143 Java class to do them a little early. Not sure why. I got in this morning and I had a little extra time, so I've already done the one for C# and I'm going to do the one for Java right now. So this is Chapter 8, Text Processing and Wrapper Classes. What you're going to notice when we go through this is it's very similar. Those of you who have already gone through the C# class, Chapter 8, you're going to notice that there are a lot of similarities. I'm not going to go through the program with you because we're going to build that as a class next week. But start running the slideshow, and you can see that what's discussed in here are introduction to wrapper classes, which we've already had. They'll talk about a few more wrapper classes, but you've used integer.parseInt and double.parseDouble before, and that's what those are. Alright, we'll talk about some of the character testing and conversion with a character class. Again, when you talk about this, there are loads of charts and stuff in the book, and I'm just not going to run through those because it really, to me, in my opinion, doesn't pay to do so. We'll talk about string objects and the difference between a string object, which is immutable, and a string builder, which is mutable. Tokenizing. Wrapper classes for numeric data types, which is kind of what's up there. And then this last thing in here is on the TestScoreReader class. So we've already talked about this before on this slide. This shouldn't be anything new to you. It says here, Java provides 8 primitive data types. Again, we've mentioned that there's byte, there's int, there's short, and there's long. Those are all whole number data types. Then there is float, and there's double. And those can have a decimal place. Alright, in addition, there is, so that's 6, there's Boolean, which, as we all know, can be true or false. And there's char, which represents a single character. So that's it. Those right there are the 8 Java primitive data types. Right there. Okay. As it says, they're called primitive because they're not created from classes. They're also known as being atomic. They can only hold a value at a time. Sometimes what you'd like to be able to do is take a variable that's one of these primitive variables and treat it as though it was a class variable. When I say a class variable, like it was more like a member of a class. So you wanted to treat it more as though it was not a primitive. So Java, as mentioned there, provides wrapper classes for all of the primitive data types. A wrapper class, as mentioned there, is wrapped around a primitive data type. There's no special imports to do with those because you already have either a java.object, which you've already got available to you. Notice there, they allow you to create objects to represent a primitive. They're immutable. That's not really said very well, but we'll get into that a little bit later when we talk about strings as far as mutability and immutability. To get the value, as it says, you must call a method, and they provide a lot of classes and stuff that can be usable. All right. Now, the character class, as it says, allows a char data type to be wrapped in objects. Well, when we start to look at this, okay, we will in just a second, but as I did in the last class, and I'm going to turn this off because I keep hearing a beep in here from that. So I want to come in here and put in the Java wrapper classes. And notice it's going to bring me sooner or later to the oracle.com stuff. And there are your different number classes. So I'm going to put that down. So again, this thing here is called, let's just use this one. Use that one. So the number of classes URL, which is right there. And it has a lot of stuff in here, including boxing and unboxing, which we're going to get into towards the end of the chapter. So I'm going to throw that in there right now too. Okay, so we'll come back to that later. So when you want to be able to take a primitive and have it do things that it would be very hard for it to do otherwise, you typically wrap it inside of one of these wrapper classes. That's hence, in other words, that's how they got their name. So here's some of the character classes. Is digit, is letter or digit, is lowercase, is uppercase, is space character. And when you look at these, they're all Boolean. Usually when you have something that starts with an is like this, it's also known as a predicate function or a predicate method. They all return true or false. True if the condition is met, so true if it is a digit, false if it's not. True if it is a letter between A and Z, false if it's not. True if it's a letter or digit, false if it's not. True if it's a lowercase letter, false if it's not. True if it's an uppercase letter, false if it's not. True if it's some kind of a space character, so hitting the space bar, a tab key, a new line, etc., and false if it's not. Alright? Notice the character class provides two methods that change the case of a character, and as I showed in the last class, and this is all stuff I think that all of you know in here. I don't mean it all to be insulting your intelligence, but if I put in my name, alright, and that's in mixed case, and I run the to upper method on it. Is it to upper or to uppercase? It's to uppercase. And that's what it's going to look like. And that's after running the to lowercase method on it. Okay, that should all make sense to everybody. Put a couple of delimiters in here. Substrings, there are boatloads of different Java string methods that you can use. In fact, again, if I come in here, Java string methods, it's going to push me to the Oracle documentation, class string, and you'll notice that when you start to look through here, there's a method summary. And you'll notice as you look through here, there's got to be 20, 30, whatever. Alright? So I'm going to keep putting this stuff in here as I build this up. Java string methods. And again, does it start with a certain letter? Does it end with a certain letter? With the region matches, there's a lot of different ways that you can check for things, as I mentioned in the C# lecture. If I wanted to check and see how many times the word ago was in the Gettysburg Address, 47 years ago, I could use different types of matches like this. There's an example. Notice that starts with is case sensitive. Okay. So is ends with. So you can check to see if different substrings, parts of a string match. Alright. So if sometimes when you look through this stuff, they talk about a needle in a haystack. So what you're looking for is needle. That's the thing that you're looking for. And what you're searching through is what's called haystack. Alright. And those are just meant to be basically, I can't think of the right word for it right now, but they're just whatever you want to search through. If I might have a real huge string, it might be a document, it might be whatever. Maybe I want to search through the Declaration of Independence, and I want to see how many times the word freedom is in there. All right, then the check is the Declaration of Independence, and the word freedom is the needle. Okay? So there's a lot of different string search methods. Here's some of them in Table 8.4, and I just gave you the URL where all of these and even more are going to be in there. A substring, again, is a portion of a string. All right? And for years, you may or may not have heard this story from me or anybody else, but for years, when people put stuff into databases, they put stuff in there like this. All right, so again, that might be the way my name is in there. But what I want is I want this to be broken up into 3 fields, like that. All right, and the reason I want that to be broken up into 3 fields like that is I'm putting it into a database, and rather than having it in there as 1 value, I'd want to put it in there as 3 values. All right, so I can use substring, I can use a split function, I can split it right here. There's all sorts of things I can do. Where you run into problems is sometimes when people put in things like this into databases or whatever, and sometimes they put it in like this. All right, so you've got to be able to both test for this and any derivation that you have of those. Okay. So here's an example again of a substring on this slide, where we want to go, we have the address of a string object, and we want to see, that doesn't make sense to have that be address, but that's fine. Let's just say it's name, and we want to check and see if the word Smith is in there, type of an idea. You can also change strings. Now, strings technically that by themselves are immutable. So just like, and I showed the same kind of an example last period, but if I come through here and I put in this, string name equals Jeff. All right, remember, I can also say string name equals new string Jeff. Most of the time you don't do that because it's just more work. Let's change this to also okay. All right. So why would I ever do that? Chances are I probably never would. But if I do that, then somewhere in memory, Jeff is put in there. Let's say it's at memory location 1000. Well, if later on in my program, so, you know, later in program, I decide, you know, I want to put my full name in there, like that. Then what happens is it doesn't go back to where that was in location 1000 and whatever and change it from Jeff to Jeffrey. It grabs a new location in memory, puts Jeffrey in there, goes back to the location 1000 that has Jeff, marks that as now being available memory or unused memory, so the garbage collector can eventually get rid of that, can reclaim that memory. All right. So if I want to modify a string, I can do concatenation, replacement, I can trim. When I trim, I can trim leading or trailing. The white space is typically how that's used. Okay. Notice this is kind of neat stuff. You can use value of. So notice if I do value of a Boolean, it'll return true or false. The value of, and if I put a number in there, it'll give me a string with a numbers representation in it, etc. Sometimes you want to use that stuff. It's kind of the opposite of converting from a string to a number. There you're converting from a number to a string. Okay? They give you some examples of using value of right here. Now the string builder is a little bit different. The string builder, whereas the string is immutable. So again, I should have said that. Strings are immutable. Alright, so I already mentioned that to you. On the other hand, if instead of setting that up as a string, I set it up as a string builder, those I can change the size of. They're mutable. So a string is immutable. A string builder is mutable. So I can make changes to it. You can change characters, insert, delete, and do whatever you want to do. So it can grow and shrink in size as needed. When you first create a string builder object, as it says, it makes it big enough to hold 60 characters. If you don't like that, you can give it a different length. So I could have put 100 right there, so it'll give me 100 by default. But once it reaches that maximum, it doubles to whatever, from whatever its size was previously. All right. String and string builder have a lot of methods in common. So when you use one, you can use another one. The biggest difference, though, between a string and a string builder is a string builder is mutable, whereas a string is immutable. All right. String builder has several overloaded methods. The append, so you can make changes to it. Okay. So notice what they have. String builder. It's not string. It's string builder equals new string builder. All right. So they keep appending to it. We sold space 12, and then space donuts for $sign. Then, so putting in these 4 append statements into the string builder string str will result in we sold 12 donuts for $15.95. The way this is often used is sort of like this, but I might have a string builder object, and I might build a person's name up. I might say, give me your first name, then I add that. Then give me your middle name, then I add that. Then give me your last name, then I add that. And then once I've created the entire string via a string builder, then I assign that to a string, because again, the string builder was mutable, the string is immutable. So string builder has a lot of different insert methods, so there's a lot of different things that you can do with this. He goes through an example with his telephone tester that's very similar to the one I showed you in the C# class, where you can put in, for example, 800-555-1212, and it'll format it for you as paren 800 paren 555-1212. So that's what this telephone number one is. You can use a lot of the string methods, like replace, etc., on here. So there's an example. So this would say, instead of we moved from Chicago to Atlanta, we're telling it to replace characters 14, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So we're telling it to replace the Chicago there with New York. So as it says, instead of saying we moved from Chicago to Atlanta, it'll say we moved from New York to Atlanta. And they have a lot of different ways that you can do deletes. There's a lot of neat stuff you can do with string builders. String tokenizers, again, identical examples to what we looked at in the last class. But here is a single string that has 4 elements in it. It's a string because it's in double quotes, but it has 4 elements: peach, raspberry, strawberry, and vanilla, each of which the character that differentiates or says when that stops is a space. All right, so there are 4 tokens in there, and the tokenizing character in this case is a space. Here's another example where you've got the semicolon in there as a delimiter. So it says some programming problems require you to process a string that contains a list of items. For instance, if we wanted to take a date here and break it up into a month, month, day, and year component, we could do that. And as it says, this process is known as tokenizing. Java provides a string tokenizer class. So as I showed you before, we looked at this. I'm wondering if I put underscore tokenizer in here, if it's going to find it. No, of course not. That would have been too easy. All right, so there's the string tokenizer methods, and you'll notice if you look through it, not nearly really as many as what you saw for string. All right. If you want to use the string tokenizer as mentioned right here, you've got to import java.util.stringTokenizer. And as I mentioned in the last class, and I'll say it again, if you look at a book, or you look at, a book's a good example. What is a book? A book's made up of pages. Pages are made up of, you know, I should say a book is made up, let's say, of chapters. Chapters are made up of pages. Pages are made up of paragraphs. Paragraphs are made up of words. Words are made up of letters. And what we're doing as I go through this and I go from more general to more specific is I'm tokenizing. All right. So here's some of the constructors and ways that you can do tokenization. And they give examples in here. Again, here it would be spaces. Here it would be hyphens. You can count the number of tokens you have. You can check to see if you've got any more tokens. You can return the next token. There's a lot of different things that you can do with tokens. So notice what they've done here. They create a string tokenizer. Okay, and it's got 1, 2, 3 in it. And what this is going to do is it says as long as I have more tokens, print it out. So it says 1, yep, there's another one. 2, yep, there's another one. 3, no, there aren't any more, so I'm done. Sometimes you have multiple delimiters. So for example, in this case right here, joe@gaddisbooks.com, you would want to say, well, I want to break this up into 3 things, either based off of an @ sign or off of a period. So there's 2 delimiters. As it says, to extract the tokens from this string, we must specify both characters in here. So there's the @ sign and there's the period. And you see how it breaks it up then into 3 tokens. Tokenizing a string object, as it says, returns an array of string objects. Okay, so you'll take something like this, which is a single string, and break it up into an array with 4 elements. And again, why would you do that? You can go either way. You can go from the 4 elements to a string or from the string to the 4 elements. Sometimes if it's a string, you might want to be able to use array methods. Sometimes if it's an array, you might want to be able to use string methods. Okay. So the numeric type data wrappers, or data type wrappers, we've looked at double.parseDouble, integer.parseInt, but the other ones work the same way. All right, you can even create new objects. So notice what this does. This, as it says, creates an object that has a value of 7 in it, but it's an object. It's the big I there. The parsing is all stuff that we've done before. I'm not going to run through these. I'll leave that up there for a second. Notice, as mentioned on the bottom, all of these different methods will throw a number format exception. So if I came in here under the byte, if I tried to put in inside of the double quotes, I put in hello. Or for the int, I put in 25.99, etc. Neither one of those would work because I'd be trying to stuff or to parse the wrong type of data in between the double quotes and then put it into a value of a non-conforming type. ToString we've looked at. We've been writing and overriding ToString for the entire semester. So as it says there, each of the numeric classes has a static ToString method that converts a number to a string. It accepts the number as its argument, returns a string representation of that particular number. Equivalents with binary and hex, etc. I'm not going to run through that. You may or may not have been aware of this, but this min value and max value is sometimes used if you want to be able to find what's the biggest integer you could possibly use or the smallest integer you could possibly use, for example. Alright, and the last thing that's really discussed in here, I think, yep, that's it, is this boxing and unboxing. And again, I already showed you a URL for this. Okay? And I'm not going to run through that right now, but let's just take a couple minutes because we only have about 3 slides left and then we're finished to just go over this. Alright, it says you can declare a wrapper class variable and assign it a value. Remember, that's a capital I. Integer number equals 7. And there's a mistake on the slide here. It says you may. It says it should be you may. You may think this is an error, but because number is a wrapper class, autoboxing occurs. So the system says, well, what really should be there is an object, but I kind of know what you mean, so I'll do it for you. So it boxes it up into an object for you. And unboxing does the opposite. All right, so this unboxes it and puts it back into its right format. Notice, as it says on the slide here, you rarely need to declare numeric wrapper class objects, but they can be useful when you need to work with primitives in a context where you can't work with primitives. So if you had an array list, what you're doing is kind of an advanced form of, what's the word I'm looking for? Casting. You're doing an advanced form of casting. And as mentioned at the bottom there, autoboxing and unboxing allow you to conveniently use array lists with primitives. So in this last example, this is the same last example that we had in the C# class, you're supposed to expect that this Dr. Harrison has 5 students in her class, each of which has taken 5 tests. Those 5 tests are set up into an Excel spreadsheet. They're then exported into the program as a comma-separated variable or CSV text file. Okay, each student's data is on a single line. You write a program that will, for each student, will add the 5 numbers together, divide by 5 to give them their average. Okay. So the last thing I will tell you real quickly is, again, is boxing and unboxing. All right, that's the one I already showed you. But there are some really good examples of this stuff out there. I'm just going to grab one here. I think that one will probably be good. So I'll put that one in also. Okay, so that'll be autoboxing, unboxing 1, and autoboxing and unboxing 2. And there's that one. All right. So I'm going to grab this example, the kind of perpetual example I've been working on for the entire period. First, let's